Hello everyone, welcome back to my YouTube channel. So on day 14 of Kubernetes series, today we are going to focus on taint and tolerations. So this is very important concept in Kubernetes which you will definitely see in real environments when you worked on. So let's understand what is taint and what is toleration. So in simple words, if I would say a taint is similar to a tag. So suppose I have one application which I want to only run on the specific or selected worker node, because in Kubernetes applications or pods can schedule on any worker nodes. But in this case we have suppose three worker nodes. In one worker nodes we have defined lot of memories and CPUs. Like basically we have set up that particular worker node to run on production level applications. So how basically we can tell to one Kubernetes, okay, I need to run this my application on this particular worker node. So for that we use taint and tolerations. So taint we will apply at node worker node level. So basically what does it mean? We are assigning a tag to worker node if any pod or any container have the toleration, means if they have the similar tag, then only you will allow to run that particular application or container on worker node. If the application or container doesn't have the same tolerance which the taint we have defined on worker node, then not allowed those pods to run on it. When we will see in demonstration that then you will see like it will be more clear. So if I would say this is something similar to labels and selectors, but in different way, because label and selectors we both applied at manifest levels. But in the case of taint and toleration, we define or we assign taint as worker node level and we assign tolerance at application or pod level. So if the value matches, like whatever the value or tag we have defined in worker node, if the same tag match with your container or your pod, then only that particular pod can run on that worker node. Otherwise it will not, Kubernetes will not schedule the pod itself. So this is the use of taint and tolerations. So here I have given one example. Suppose you have a one spatial node with a GPU and you don't want regular pods running on it, so you taint it and only GPU pods will be allowed. So tolerance we will define at application pod level and taint we will define at or we will assign at worker node level. There are effects also which we have to use when we assign or when we add a taint on worker node levels. There are three tags: no schedule, prefer no schedule, and no execute. So when we assign a taint to a worker node level, we have to add the effect as well. So the very first effect is no schedule. So don't schedule the pod unless they tolerate the taint. What does it mean? If we have added a taint with no schedule effect, then if the tolerance or if the application pod doesn't have the same toleration which we have assigned at taint level, in that case your application pod will not schedule on that machine. If they will find the matching tags in both node and pod, then only your application pod can run on that particular worker node. Second, we have prefer no schedules. So this is like avoid if possible. It is soft. Like basically there is no guarantee. So your application pod can run on that worker node or cannot run. So there are chances, like there is no guarantee your application pod can run on the specific node. So for that purpose we use prefer no schedules. Another one is no execute. So what does it mean? If you are using a no execute effect with taint, so it means if you have existing pod running on that worker node, it will remove that pod also. And if you are scheduling a new pod, that pod also will be evicted or restricted, like it will not run. So these are the effects we can use when we define taint and toleration for our Kubernetes resources. So we will see in demonstration, then it will be a more clear. Now what is toleration? So we have already discussed that toleration is a setting on pod that allow it to run on a node that has been tainted. So again, like worker node label, we have assigned a tag. Now we need to match that worker node tag with our application pod. So for that purpose we can use toleration. Okay, let me go to a next slide. So because I have already explained these things, so let's understand with the help of this diagram. Suppose I have three nodes, node A, node V and node C. And worker node A we have not tainted, like there are node tagging we have defined. It means this is very simple worker node, like usual. Second, we have a worker node B where we have taint, like key equal to GPU and value is equal to true. And effect we have defined no schedule. So if our application pod will have these tolerance, then only it will allow pods to run on this worker node. If that pod doesn't have, then it will not allow. Third, we have node C. So here again we have same concept which we have defined here. We have taint, key is special, value is dedicated, effect no schedules. What does it mean? If our application container will have these tolerance, then only it will schedule the pod on this worker node, otherwise it will not schedule. So let's take example. Here we have three pod, 1, 2 and 3. So for one pod 1 we have no tolerations. This is a plain pod. Second, we have pod 2 which is tolerate with this key value pair, GPU is equal to true. Third, we have again a toleration with key and value. Now this pod 1, on which worker node it can schedule, node A, B or C. So this pod 1 can only run on pod A because there is no taint. This is the plain worker node, so we can run application pod 1 on this worker node, and we cannot run pod 1 on node V and node C because these has been tainted with these key value pairs, and this pod doesn't have any key values or toleration, so this pod cannot schedule on node V and node C. Similarly, we have pod 2, which is again we have defined a toleration GPU is equal to true. Matlab means this is the key and value which we have defined to this particular pod. Now this pod can only run on those worker node which has tainted with this key value pairs. So in our case we have node V which is tainted with GPU and true. So now the pod 2 can successfully run on node B, but it cannot run on node C because here we have a different key value pair and it is not matching, so it will not allow to run pod 2 on this worker node. Now if we talk about node A, so on node A this pod can run because there is no taint we have assigned. So this is the plain worker node and this pod can easily run or schedule on this worker node because here we don't have we have not tainted the worker node, right? Similarly, pod 3. So pod 3 can only run on node C and node A. It cannot run on node B because it is not matching with the taint with tolerant too. So because the key value is different here and here we have tainted with different key values well. So ideally we use taint and tolerance if we have a specific worker node which we want to utilize, for example any AI workload or maybe production level. So for that purpose we generally use taint and tolerance in real time. Now we will see the use cases. So reserve nodes for production workload only, like these are the use cases where we can use taint and tolerance, right? So the very first is for production workload level, for development and test pod of crucial nodes, like for this purpose also, if we want to protect node with special hardware, like we have given GPU and SSD, in that case also we can use because for these expensive resources we cannot use for development purpose. We need those resources for production level workload. So they depend on the use case. We can choose a worker node which has that much capability to handle that particular load which we are thinking to schedule on that particular worker node. So in summary, taints are like guards at the gate of node. It means they will check, do you have a pass to enter? If application or container will have a pass, they will enter onto the worker node. If they don't have a pass, they will not enter. So in technical words, we are using here key value pair format. Like if the key and value match with the both, like the worker node and application container will have the same key, then only it will allow to run the pod, otherwise it will not allow the pod. So this demonstration we are going to see in our Docker desktop, and in our case basically we have single node cluster, because Docker desktop we can use single node worker cluster. So we can, but we can see a real-time demonstration on that. Now let me go to my GitHub repo, and let me go to folder which is day 14. So these are the steps I have mentioned here, which we are going to follow as well. So what we are going to do first we are going to deploy our normal application, normal pod in our Kubernetes clusters. Then we will use taint with effects. So let me okay, so first I will go with this file, because here we don't have any taint and toleration. So let me open my Visual Studio Code. Okay, let me copy the name as well. Okay, let me move to on this screen. Okay, so now let me create a file with pod without tolerance, because we are not going to specify any tolerance, means we are not specifying any key values here. Okay, so now let me go back to my GitHub and let me copy. This is very simple pod.ml file. Okay, let me save it. Now first what we will see, let's verify how many worker nodes we have. kubectl get nodes. So we have single node, which is Docker desktop, right? Now what I'm going to do, I'm going to deploy this nginx container on this worker node. So if I run kubectl apply hyphen f and file name. Okay, so if I check the status of pod, kubectl get pods, so we can see one container is created. If I rerun it, we are saying we are running one pod, or 1 out of 1, which is running fine. Now what we will do, we will taint this worker node, which is Docker desktop. Okay, so let me type the command docker kubectl taint node and node name, which is docker hyphen desktop, and here we will use a key value like environment colon prod, sorry, not colon, operator we have to use, environment is equal to prod, and then we will assign a effect. So let me see, no schedule. Okay, now let me run it. Okay, so spelling mistake, let me correct this, kubectl invalid taint effect, no. Okay, I think so the s should be, okay, again is it spelling mistake, no schedule. Okay, so now we have tainted our worker node, which is Docker desktop 1. You can see the output here is tainted. Now let me clear the screen. If I will see the kubectl get pods, okay, again typo, kubectl get pods, so we can see one pod is up and running, but we have tainted this worker node, so we are using no schedule. What does it mean? It will not schedule any pod, but it will not remove or restrict the existing running pod, right? So for example, this is the one pod which is already running on this system. Now what I will do, let me go to my GitHub repo. So here I will okay, so for now we have created a pod with no schedule effect. If to verify it, I forget to show you. So what we can do, let me copy this name, kubectl describe pod and pod name. So here you can see default scheduler, no toleration pod. So there is no events for toleration because we have not specified. Now what we will do, we have tainted this worker node with no schedule. So it means if I will try to schedule a new pod, that pod will not be scheduled on this worker node. So for example, if I will change the pod name here, let me change it with pod 1. If I will run this worker node, this ML file, if I will apply, let me do that, kubectl apply -f and pod. Now if I will check the status, kubectl get pods, okay, again typo, kubectl get pods. So you can see the status is pending because it will not schedule the new pod because of the taint and toleration which we have defined. Because this pod doesn't have any toleration, so it is not allowing to run the pod or schedule the pod. To verify it, what we will do, I will copy the pod name, kubectl describe pod and pod name. So here you can see warning, failed schedule. So Kubernetes itself will not schedule that pod. So you can see the from default scheduler, 0 out of 1 nodes are available. It means there are no nodes available where we can schedule this pod. One node has intolerant taint environment prod. So we have only single node which is tainted with environment with prod variable like key and value. So it is restricting the new pod to schedule on this worker node. If I will clear this, what I will do, if I will add here, let me copy paste it. So if I'll go with here and if I will copy this part, okay, mapping issue, it's fine, let me correct this. Okay, so here we have key is environment and value is prod. So as of now, cubes, let me verify the pod, kubectl get pods. So we have one pod is running, the new pod is, which is pod 1, is pending state because of no schedule policy, we are not able to deploy this pod to a worker node. Now let me apply this command, sorry, the latest changes which we had added the tolerance, kubectl apply -f, sorry, kubectl apply -f and file name. So file name is pod. Okay, so invalid value mapping issue. Okay, let me do one thing, let me take the full command, sorry, full code. What I will do here, I will, okay, let me take it again. So what I will do here, in the name I will add it here 1, so to differentiate. Now what I will do, I will rerun this file. Okay, if I will check kubectl get pods, now we will have a 2 pods with this name toleration pod 1, and this pod still we will see in pending state because this is not scheduled itself. So if I will rerun it, so now you can see we have 2 pod which is scheduled or running on this worker node which is Docker desktop. This is in pending state because of the policy, or because of the effect no schedules. So that's how we can use uh, no effect with taint and no schedules with taint and tolerance. Now let's see one more example. Let me close this file. Now we will see the taint and tolerance with no execute effect. So for that, what I will do, I will open this file. So here everything is same. What we are changing here, we are changing here GPU and yeah, effect, which is no execute, and here we are adding a tolerance second 60, because this will pop, this pod will not evicted immediately but after 60 seconds. If we will remove this tolerance seconds, then our pod will not evicted, it will run as it is. So earlier we have tainted our worker node with environment is equal to prod key value pairs, or in simple words if I would say, or tag. So we have to untaint first. So for that, what we will do, here I will simply put hyphen and enter. So it will untaint our worker node. Now we have not, so now we don't have any tainted on worker node. We will create new tainted. So as of now, if I will verify my pod, kubectl get pods. So now we have 3 pods up and running. Now this pod why is running? Because we have removed the taint from the worker node. That's why it is scheduled the pod and it's running. Now let's see how no execute effect work. So for this, what I will do, let me copy the code here. Okay, let me delete this content and let me save it here. So here what I will do, I will taint my worker node with GPU is equal to true key value, and the effect will be no execute. So let me do thing. So what I will do, I will change this part. GPU equal to true and colon no effect. No execute. So now what this basically do, this taint what it will do, no execute effect. Whatever the existing pod which we have in running state, that will be immediately evicted, and we cannot schedule a new pod as well if that pod doesn't have this tolerance label or this tolerance tag. So if I will run this, now our work desktop is tainted with no execute. So if I will list my pods, so you can see it will immediately remove it. If I will refresh again, so you can see no resources found in the default namespace, because these applications or containers we have deployed with no schedule effect with different tolerance label. Now this worker node we have assigned different tolerance label. Now if I will schedule this pod, if I will run kubectl apply -f and file name, and if I will see the pod kubectl get pods, so you can see with the name of this pod it is creating a container, because now this pod has this key and value which we have given to a taint or worker node. So if I check the pods, so now you can see the pod status is running, but this pod will run only till 60 seconds because we have defined here tolerance seconds. So till 60 seconds it will tolerate, and then it will remove it. So to check it, let me put -watch flag. So it's 38 seconds. Okay, let me cancel it, and okay, let me clear the screen so it will be more visible. Okay, now let me again rerun it without watch flag. So you can see no resources found in the default namespace. Now our application has same, or application container has the capabilities to handle the toleration level, because we have defined the correct key and value pair which we have used to taint our worker node. But still it is removed our application or container from this worker node because of this parameter. If I will remove this parameters, then our application pod will execute like until we will not remove it manually. So if I will apply this file, now our container will run as it is, like a normal mode, basically normal mode. So now you can see status is running and it will continuously run, because there are no toleration seconds which we have specified here, the parameter. If I will go back, toleration seconds, because we have removed this toleration seconds, so it means this the worker node can only tolerate this container till 60 seconds. After 60 seconds it will immediately evict the container or remove the container. So that's how basically we can use taint and tolerance with no execute effect. So I hope it's clear how we can use taint and tolerance in our Kubernetes resources, and it is very useful when you have dedicated servers or worker nodes to assign a particular workload on that. On that purpose we can use taint and tolerance. So that's all for today. I hope it's clear. In case if you have any doubts, you can definitely ping me over comment box. So that's all. See you in next video. Thank you so much.